Imagine you're on a spaceship traveling at the speed of light. Would you ever reach the end of the universe? It's a mind-boggling question, isn't it? The universe, in its stunning vastness, defies our everyday understanding of distance and time. Even at the speed of light, it's a journey that seems to go on forever. This is the concept of infinite space, a realm so vast it's like an endless ocean of stars and galaxies. But how can we comprehend this vastness? Let's dive into some comparisons. To truly grasp the immensity of the universe, we need to compare it to things we can understand. Let's start with our home planet, Earth. It's a vast world, isn't it? With a diameter of roughly 7,920 miles, it seems immense. Now, imagine 100 Earths lined up next to each other. That's roughly the diameter of the sun. Quite a leap, isn't it? But let's not stop there. Picture 1,000 suns lined up. That's roughly the distance from the sun to Jupiter. Yet this colossal distance is but a fraction of our solar system. The solar system, with all its planets, asteroids, and comets, spans roughly 5.5 billion miles. Now, let's take it up another notch. If we were to line up 1.5 billion solar systems, we'd just about reach across the Milky Way, our galaxy. That's right, our entire solar system is but a tiny speck in the grand scheme of our galaxy. But how do we measure such mind-boggling distances? Well, astronomers use astronomical units and light years. An astronomical unit, or AU, is the average distance from the Earth to the Sun. It's about 93 million miles. A light year, on the other hand, is the distance light travels in a year, which is roughly 6 trillion miles. So when we say the Milky Way is 100,000 light-years across, we mean that if you were to travel at the speed of light, it would take you 100,000 years to cross our galaxy. And remember, the Milky Way is just one of over 2 trillion galaxies in the observable universe. Even with these comparisons, the universe's size remains mind-boggling. But what if we could shrink it down? Imagine for a moment that we could shrink the universe down to something more manageable. Let's embark on a captivating thought experiment. Picture a bustling metropolis, teeming with life, lights, and sounds. Now imagine that this city is actually our universe, shrunken down to a size we can comprehend. Each towering skyscraper would represent a galaxy, each window a star, and each tiny speck of dust floating in the air, a planet. Now let's take it a step further. Let's shrink our universe city down to the size of a house. Every room becomes a galaxy, every piece of furniture a star, and every dust mite a planet. Can you fathom the sheer number of celestial bodies we've just squeezed into an average-sized house? But why stop there? Let's shrink our universe house down to a single coffee cup. Each drop of coffee represents a galaxy, each caffeine molecule a star, and each tiny sugar grain a planet. This incredible thought experiment illustrates not just the vastness of the universe, but also the fact that our human minds struggle with comprehending such enormous scales. Even when shrunk down to the size of a coffee cup, the universe is still teeming with countless galaxies, stars, and planets. As we can see, even when shrunk down, the universe's size is astonishing. But is the universe truly infinite? The concept of an infinite universe is mind-bending. But does the universe have an end? Let's dive into this. The universe as we know it is bound by what we can observe, hence referred to as the observable universe. This is determined by the cosmic light horizon, which is essentially the farthest point in the universe from which light has had time to reach us. Now imagine this. The universe is like a gigantic cosmic web, a 3D tapestry of galaxies, stars, and cosmic dust, all interconnected. But our view is limited. Just like standing on a vast plain, there comes a point where our sight can't reach any further. That's our cosmic light horizon. However, beyond this horizon, the universe doesn't just stop. It's believed to continue, perhaps infinitely. But due to limitations in our observational capabilities, we can't confirm this. We may never know the true size of the universe, but we do know it's incredibly vast. In our journey through the cosmos, we've seen the universe's immense scale. We've discussed the speed of light, a concept that helps us grasp the vast distances between heavenly bodies. We've delved into astronomical units and light years, terms that bring the universe down to a more human scale. We've explored the observable universe and pondered the concept of infinite space. The universe's size is beyond human comprehension, a testament to the grandeur of the cosmos. So next time you gaze up at the stars, remember you're looking at but a tiny fraction of the infinite universe.